Our intrepid designer Jimmy likes to think of himself as a good engineer, someone who understands how things work. Jimmy likes to know the answers. But today, he was stumped by a question from his 6-year-old niece Lucy while watching the Dos Asai Atlantis 500. Lucy asked why the cars ran so closely behind one another. Jimmy was happy to explain that this is called drafting. The first car makes a hole in the air, allowing the following cars to run just as fast, but use less engine power. The following car can then pull out and use this power reserve to overtake the lead car. Lucy was quiet for a moment before saying, "But how can that work? When the second car pulls out, it has to make its own hole in the air, so why doesn't it just slow down?" Although floored by Lucy's insightful observation, Jimmy blustered about vehicle momentum and such, which seemed to satisfy Lucy, but to be honest, he really didn't convince himself. Now, Jimmy hates not knowing, so he fires up SOLIDWORKS to find the answer to Lucy's seemingly simple question, but a question that involves some pretty complex aerodynamics. Using flow simulation to solve Lucy's problem is very straightforward. In effect, we are making a virtual wind tunnel. And just like a wind tunnel, we have to set the car speed as the air velocity, in this case, 150 miles per hour. And after setting the road and walls conditions, Jimmy is ready to solve this problem. To visualize the aerodynamic interplay of the two cars, Jimmy plots the airflow velocity, because he knows that the lower the air velocity is hitting the car, the lower the air resistance the car experiences, which equates to a lower engine power demand to run at a given speed. Jimmy can see that even with the cars more than 6 car lengths apart, the following car, car 12, is positively affected by the wake of the lead car, car 43. The air velocity hitting car 12 is significantly lower than the race speed of 150 miles per hour, and this in turn will help car 12 catch car 43. Jimmy is able to measure the lift and drag experience by the cars as they draw together, and is surprised to see that the lead car is also favorably influenced by the following car pulling up behind it. Once car 12 is tucked in behind car 43, the drag car 12 experiences is about half of what it was when the two cars were 6 car lengths apart. But at the same time, car 43 gets a 15% reduction in its drag. This means that as a pair, the two cars can run faster together than they can apart. As car 12 pulls out to overtake, it experiences a sudden rise in its drag as it feels the full impact of the air. But at the same time, car 43 also experiences an increase in drag. And while the increase in drag for car 43 is not as dramatic as that for car 12, car 43 has no power reserve. The overtaking maneuver actually slows car 43 down, helping car 12 to accelerate past. As car 12 continues to move ahead, its drag continues to rise, and the success of the maneuver is now down to engine power. If we assume they both have engines of roughly equivalent power, then car 12 should be able to complete the maneuver successfully. But with the same engine power, car 12 will have difficulty pulling away. So now, car 43 is in the draft of car 12, and the overtaking waltz can start all over again. Thanks to SOLIDWORKS Simulation, Jimmy now has the answer to Lucy's question, and the answer was more than he was expecting. By using flow simulation, Jimmy now has a better understanding of how race car dynamics affects the car's speed, but also its handling and tire wear. For Jimmy, this is the icing on the simulation cake. He always learns more than he imagined about a problem or product from asking a simple question. Just like Jimmy, all companies can benefit from using simulation. Simulation is not just about will it work, it's also about how does it work. By understanding the fundamental physics of a problem, you can come up with innovative solutions that your customers will want. Although the simulation of real-world problems might seem daunting at first, SOLIDWORKS Simulation gives you the power to solve complex problems without complexity. By giving you greater understanding of how your product will perform, SOLIDWORKS Simulation gives you the vital information you need to make good engineering and design decisions, making your products better and your customers more satisfied. To find out more about SOLIDWORKS simulation tools, contact your local SOLIDWORKS reseller or explore the site further.